So we are continuing from where we have left on last lecture that we were discussing about the drawbacks of prototyping. For a quick recap, let us understand again for what it was we discussed on the last topic. What was prototyping? And prototyping generally means to create a miniature or a dummy require like system for the customer to have a look and feel about the system, whether the system is working, is has a required functionality or not. And this type of approach is generally used when both the customer and the developer are not confident enough. That means the requirements are not well understood and reasonably stable. Okay, so we continue from this point, but before we continue, let us revise some basic knowledge. And okay, this review question is dash defines a framework that must be established for effective delivery of software engineering technology. Now, what is the basic framework? Okay, this framework is called process. This is not SDLC. It's known as a process defines a framework. SDLC is a generic process model, but this process is the keyword for this type of question. Second is dash is used where we have requirements that are well defined and reasonably stable. The answer is very clear because we started with this particular model. The answer is waterfall model. The waterfall model is used when we have the requirements that are very well defined and at the same time they are reasonably stable. That means they are not going to change in the due course of the development of the product or the software. Third, dash development is particularly useful when staffing is unavailable for a complete implementation by the business deadline. So when the term staffing comes in, we are moving from a generic waterfall model to a classic life cycle model to an iterative based models. In iterative based model, I have two sub models. One is called the iterative model, and one is called the RAD. In RAD specifically, the staffing is enough for us, okay, but the constraint is on time. But in incremental model, the staffing is itself less, okay, so we have to deliver that particular product in increments. So the answer comes to be incremental model. And the two requirements for using RAD model are, first of all, we should always remember that RAD is rapid application development. That means you need to develop very fast. So first requirement is that you have to modularize each and every module, and you have to divide the work into teams. The team will work in parallel. Secondly, the development time will be 60 to 80 days. That means modeling and construction should always be uh, 60 to 80 days. But for this type of model, the first requirement is the requirement should be very well understood, because then only you can divide it into teams. Otherwise, if they are not well understood, you cannot divide it into teams, or in another sense, they might overlap. Okay, or some team might be waiting for input from another team. In that case, RAD will not be a successful model. The second is the project scope is constrained, that is 60 to 90 days for the development activities. In a dash prototype, the developer attempts to make use of the existing program fragments or applies tools that enables working programs to be generated quickly. So we have discussed that in prototype we have two type of prototypes. One is called the throwaway prototype, and one is called uh, we use that prototype. Okay, and that this is the case when it says that the developer is going to use whatever prototype he has made, and he will enhance that particular prototype to generate the working program. So this is called as a working prototype. Okay, now let's begin. If we are now we have done a quick recap of all the concepts that we have studied in the last lecture, software engineering part 1. So let's now begin with the new model, which is called a spiral model. Spiral model couples the iterative nature of prototyping with the controlled and systematic aspect of waterfall model. Now we want to combine both the functionalities, that we want a sequential approach, a systematic approach that was there in waterfall model. At the same time, we want to iterate within the system, within the uh, particular process activities, SDLC activities, so that we can confirm that each step is applied many times. Okay, we want to enhance the functionality in multiple iterations, not in one go. In one iterations, the user will have the look of feel of a particular system, then he can see some functionality, and finally he can see many other functionalities. So a spiral model couples the iterative nature of the prototyping. That means it gives small prototypes, small increments, whatever you can say, and it is a systematic approach also. But it has two basic distinguishing features. The first is it follows a cyclic approach for incrementally growing a system degree of definition and implementation while decreasing its degree of risk. So at the same time, that if you see this, if we are going in a cycle, okay, it has one cycle, and in each cycle, the risk has to be addressed and has to be mitigated. You have to mitigate the risk also, and that's why there is a special component in the spiral model, the sixth phase of what you can say SDLC, which takes care of this risk. And secondly, it has a set of anchor points for ensuring stakeholders' commitment to establish and mutually satisfactory system solutions. So anchor points, you know what are anchors? Anchors are, if you have seen ships when they comes to the docks, so they have an anchors that will be helping us to stop that ship. So likewise, in the anchors here means where you will stop the development for a while, and then you will take the feedback from the users or the customers, and once you get a feedback, you will incorporate that feedback and then go ahead with the development. This is called as the anchor points. So let us see how this spiral model looks like. Spiral model generally have a system like this. You can see that we start with customer communication, okay, then we move to planning, and in the planning phase we are moving to a risk analysis phase. So we are moving from planning to a new phase which is called as risk analysis. That's what a part of the planning in we have discussed when we talk about what you can say waterfall activities. But now we can see that planning is one part, and we are moving to risk analysis as a secondary part. Now from say risk analysis you are moving to a modeling or engineering part, and from engineering to construction and release, and finally you have a customer evaluation also. Once you are done with customer evaluation, you are having the anchor point. This anchor point generally helps us to take the feedback of the evaluation, whatever things have been given by this evaluation. We will take all the requirements here, okay. Project entry point axis, okay, this is the axis that tells us this where we have to start. We started from here. So now what we have, what will we do? We will again go to communication, planning, and risk analysis. So if you can see the different shades of the circles, you can say first white circle is the product maintenance projects, okay, the concept development projects. So we started from here inside the graymost circle. So we started from the concept development projects. This is what is done in this gray part, darker gray, the dark is inner circle, which develop the concept. Then when we go out of this gray darker area, there's a certain lighter area around this darker shade area. This is about new product development projects. Okay, whatever now, what are the concepts we have done? We are going to implement the concept in a newer project, right? Then the third row is all about product enhancement projects. Okay, now once the product has been done and delivered, now the thing is student like customer now asks for enhancements. Enhancements means adding a new workflow or adding a new screen or changing the workflow. So you are doing that particular thing in this particular part, and finally, once the thing has been done completely, enhancements are also incorporated, new developments is also incorporated, the concept has been developed and matured in three different releases. Then in that case, the customer gives this into a maintenance phase. Now the customer, the product has been delivered finally, and you have to maintain it for a certain period of time, and we call this we through certain contracts, because the annual maintenance contracts or AMCs. You heard this name AMCs when we if you have someone working in some industries, the air conditions or the systems that we install comes with a AMC. Okay, and in AMC you have to maintain it through certain set of years. So once you in the white line shows the maintenance of the product, and finally uh, project entry axis, and it's out of this like maintenance phase also. So this was a small overview of how spiral model works. But actually, what are the phases in this circles is not clear from this particular diagram. So we will see broader things like this. That first, inner circle is all about reviewing the document or reviewing the concept. Then again, a risk analysis phase is there. After reviewing this requirements and whatever things have been given by the customer, and analysis that has been done by the customer, that our team, then we develop a prototype one, right? Prototype one is the earliest prototype, or whatever you think the requirement would look go into a product. Then you concept of operations, you develop a concept for the operational product, and requirement plan, life cycle plan. Okay, requirements plan now develops, because okay, the customer will say yes, I'm good with this prototype. Now these are my plans. Now actually you are refining this requirement, and you are refining the life cycle also. In the second stage, you are again doing a review. Okay, determine objectives, alternative on constraints in this part, and then do a risk analysis. Then you are doing a simulation models and benchmarks, software requirements, requirement validation, and then you are doing a development part. Okay, and a third cycle has the development phase. Again, you are determining the objectives, doing a risk analysis. Prototype 3 is being created. Product design now start building. You are now converting the requirements back to design. Then you are testing you're creating a V&V model that we call as validation and verification model for the design. That these are the design, and this is how you will test the design. Okay, then you have to create integration plans also, that if there are 30 modules in the system, then one module will be tested in how many ways. Okay, once we get all the 30 modules ready, then how we will integrate these 30 modules, and now we will test end to end everything. So this is the integration plan here. Finally, we will do a risk analysis of the integration plan. Operational prototype is being created. Now this is closely linked with the final product. Okay, detailed design will be created, coding, unit test, integration test, acceptance test, and the service. This is maintenance phase comes in, and now your product is been delivered. So this is how a particular spiral model actually works in industry. That in each circle, in each cyclic point, you are having some anchor points, and at the end of the anchor points, you can see like this, let us this be an anchor point. So at this point you are getting the concept, at this point you are getting the requirements, at this point you are getting the design, or at this point you are getting the final product. Okay, so at each anchor point I get certain outcome, a work product coming out, and I can show this work product to the customer. And if you can see this part, at this point, you are having a prototype 1 to be shown to the customer, prototype 2 that can be shown to a customer, prototype 3 that can be shown to a customer, and this is prototype 4 that can be, or operational module that can be shown to the customer. The customer also gets, in each stage, he can get a look and feel or understanding better and better. He can add more requirements, he can delete certain requirements, he can add certain design specifications, he can remove certain design approvals also in that case. So this is the spiral model, how it actually works. So spiral model generally is applied throughout the industry, and because it adds each increment adds certain level of more understanding in that particular development. Now, in industries or in general case, we do not believe in developing module from scratch always. Okay, we need to develop certain modules from scratch, but in general case, why should we invest time creating the modules when it is already there in the market? We can buy that particular product or the module, or we can integrate it with our system. So now the come the we will study the component based development. It incorporates many characteristics of spiral model. That is, it is evolutionary in nature, demanding an iterative approach to the creation of the software. However, the model compose applications from pre-packaged software components. So the name comes from that pre-packaged software components. So we are heavily dependent on the pre-packaged softwares. Like RAD specifically work with component-based development. I have already discussed in the last lecture that you have already used uh, stdio.h header file in your C programming lab. That particular package, or if you use Python, if you use Java, there are many packages, and these packages generally help to reduce time, as well as at the same time what they do is they will add a standard definition to our system. Okay, because these packages are created with the intention that the things will be done the same way. It's the same case as given you example of McDonald's. So if you go to McDonald's in Aligarh, or if you go to McDonald's in Delhi, if you go to McDonald's in Hyderabad, you get the same taste. Why? Because the component that you use, or the process that you use, they are the same. Okay, so giving a standardization approach, or a similar approach, or you can say a uniform approach, is the main reason for prepackaged components. At the same time, they reduce the working time, and they reduce the testing time of a software. These pre-packaged software components are called commercial off the shelf COTS software components. Okay, they are developed by vendors who offer them as a product. So commercial off the shelf component means someone who develops this software, these components. The easiest you can understand is you have seen a calendar control on any many web pages. Okay, so the calendar controls now comes as an, you can say, API, or you can say you can import that particular thing instead of creating a code for a calendar control. You can just import that particular file in your system and you can implement this. So C2OS generally is I can buy a product for my system. I can generally can make my team understand that particular thing, or it can be done in multiple ways. But regardless of the technology that is used to create these components, the component-based development incorporate the following steps. First, available component-based products are researched and evaluated for the application domain in question. Okay, whatever application domain I have, so I will do a research and I will find out whether the component uh, that I'm searching is available or not, first of all, and whether if it is available, then what is the utility of that particular component in my application domain. Okay, all component integration issues are considered. So if I will already take care of these type of things, if I integrate this, because question is this, I haven't developed this component. So if I put this component in my system and I have integration issue, I will not be able to resolve it, okay, on my own. Okay, then in that case, either I have to detach this component from the system, or and then search a new component. So I have to do a research whether if I add this component in my system, whether the system will have more issues, or it will resolve my query. Okay, so we have to do some research also in that case. A software architecture is designed to accommodate the component. So you need to understand whether the architecture that you follow. We will see what are software architecture in the design phases when we talk about third unit. But as of now, you develop a module, okay, a bigger diagram in which you will see that my system has some 30 40 modules or 10 modules, and how this component is accommodated in that particular design. Components are integrated into the architecture and comprehensive testing is conducted to ensure proper functionality. This is the basics things that you need to do once you choose a component based development. Now, the assembly model is something like this. You identify the candidate components. The first thing, you find what type of components do you need. Then you look up for the component in the library. That means say, like header files, or you can say your own infrastructural files, that you have a similar component like this or not in your system. If you have, this is available or not. So if you have availability, you extract the component and construct the system. Okay, if you don't have that particular component or similar component in your library or in your packages, then what you do, you will go and build the component. This is the only option left. You can go and build the component, or you other have, you can buy out that particular thing and then construct the system. But in buying out, you have the risk that the system, because the component is not yours, you do not have the technical knowledge, so you can end up in a mess. Okay, so in that case, what is preferable is you buy the component, you get the team trained on the particular like technology, and then construct the system. So once you have issues, then your team can resolve it. So this is the assembly model, component assembly model. This is one of the part of the RAD model also, because the RAD model heavily depends on the component based development due to its constrained scope. So the main characteristic of component based software is it makes intensive use of existing reusable components. The focus is on integrating the component rather than creating them from scratch. This is the main objective of the component based design. Due to this, it has certain advantages. It reduces considerably the software to be developed in-house. That means the time that is you will spend on creating the components is hugely reduced, and now you can develop certain modules which are really important. They are not there. That are your own concepts rather than working on certain concepts which are easily available in the market. So it allows faster delivery, in principle more reliable systems due to using previously tested components, because we are using the component that has been already been tested thoroughly by the industry in many places. So we are essentially, it ensures us that if we incorporate the component, the testing will not be, it should not be done so thoroughly, okay, rigorously, because these are already tested components. So it reduces the testing time as well, and it makes the system more reliable. But it has a disadvantages also. It compromises in requirements are needed. That means when you incorporate a component, the component itself comes with certain constraints. Okay, you cannot if you want to use the component, you have to make certain compromises with the requirements of that you have already coded. So might be possible to you go to negotiations again, and then you will try to redefine the requirements for incorporating that particular component, and you have less control over system evolution, because this component that you have taken from the vendor, now you don't have control over the system evaluation. Like the coding part is not done by you. So even if you know the code, but it's because it's not yours, so you have less control on its system. When there is a pool of existing components that could satisfy the requirements of the new product, that means applicable is this type of component based system can be used when I have multiple components available. Okay, I can choose which component to use from a pool of available components that satisfy my requirement. But if this is only one component that can satisfy my requirement, is better, and that too has been developed recently, it's not stable release, then I will try to develop that particular thing for my own scratch work. Emerging trend, that integration of web service from a range of suppliers. This is how you do, right? Web services right now, if you want to use web services, we already have components that do this. Okay, Now, if you, the easiest thing you can say that I want to incorporate a data exchange, particular how to exchange data. So generally, you when you use Oracle, you have ODBC, and when you have GDBC. So these APIs helps you to don't code the data, just you pass your data. It will take the data to the database. It will do the whatever backend thing he has to do, but it will give you the back the response. So it reduces your time to create the APIs. Okay, that's why we create APIs, application programming interfaces. So this was all about component-based software engineering. The next is a unified process model that sir was discussed as RUP. Unified process is a use case driven architecture centric iterative and incremental software process closely aligned with a unified modeling language. So this type of process generally is highly dependent upon UML models that we have studied in our classes and previous lectures also, that we have multiple UML diagrams like use case diagrams and class diagrams, sequence diagrams, activity diagrams, swim lane diagrams. So we this process depends upon heavily on these type of diagrams and how they get converted. So you can think that the phases remain the same, but within the phases there are certain steps. Communication is one of the phase of what you can say development activity. From communication, you are going to planning, and between these two, there is a stage called inception, right? Inception is one of the stage in which you take the requirement from the communication phase, and from the requirement you are trying to do certain analysis, and you try to figure out what are the planning activities that you need to do, and this is the helping hand between in communication and planning. From planning you are moving to modeling, and in that case you are using elaboration, one of the key terms we have studied in requirement analysis also, engineering also. We are elaborating the communication part, and then finding what are the things are required for modeling. From modeling was done, there is no phase. From construction is a construction phase. From constructions to deployment there is a transition phase, and finally from development is done, you are having software increment. This is called the production phase. Okay, this is the small diagram for unified process model. So you can more study about this from your textbooks of software engineering practitioner approach by Roger Pressman. You can use any release edition, like 6th edition, 7th edition, 8th edition, or 9th edition. The data, the concept remains the same. Okay. So I hope you can study about this in your own, and if you have any doubt, you can come up with the doubts in the class or on the classroom, Google Classroom. Now, one of the recently developed model is called agility. Okay, it's called agile software. One of the recent models that is actually used in industry is called agile, and it's generally asked in what you can say in interviews also. What is agile? What is agility? Okay, agility means to effective response to change, the rapid and adaptive response to change. That means whenever there is a change coming up, how fast you can accommodate that change. Okay, so if you are if you have given one increment and the customer sends you a feedback back, if you having certain things that you can incorporate right now in the coming release, you can do that. You don't have to push that particular requirement at the end of the 7th release or 8th release, because sir, we have already lined up the requirements, we cannot take my now this is a new requirement. You cannot do that. Customer has requested you a new requirement and he is in a rush to see the requirement. You have to incorporate that particular thing. This is called agility. Effective communication among the stakeholders, that means all the stakeholders should know what are the new requirements coming up, what the new release has to is going into. So once you, if you install something from Google Play Store, or if you go and install something from suppose any iStore, whenever you have an update, you can see the update history, you can see what is actually this update is doing. Even if your mobile phones you get an update, Android or iPhone, Then you can, when once it installs that update, he will give you a summary. He will say that this is what we have done, okay, a security patch or a bug fix or a whatever thing he has done. So this is what, because you are a stakeholder of that particular system, so he tells you also, okay. You are not bothered what the thing may be, okay. Security patch, you do not know, you might not know, because you might not be from a computer background. Someone who is not from a computer background, he cannot know what is security patch, but the responsibility comes to the vendor, to the development system. It tells you that this is what we have done. So it is called effective communication. Drawing the customer onto the team, that means the customer now feels that he has given certain inputs, and the inputs has heard and got implemented. So it's more loyal, more reliable communication, okay. Now customer also feels like, okay, if I say something and it is heard and it is being responded back by a team, now I'm a part of the team. Fourth is organizing a team so that it is in control of the work performed. So I need a very effective team now, and where we talk about teams also. Okay, I will go and create one lecture, because this is software teams is one of the topics of the second unit. So that this is a team approach. It's strongly built on the team approach, agility. Okay, you should have a very strong team, and that team should actually deliver these responses well in time. So now, if we know what is agility, now we can define a process which applies this agility, and we call this an agile process. It is driven by customer description of what is required, that is scenario. Now, this process actually is defined by the customer, and now it is not defined by what you think and when you should deliver that requirement. The customer has more control on that particular thing. It recognizes the plans for are short-lived. That means your plans, requirement plans, are very short-lived. You get one requirement, you have to develop the requirement in very small amount of time. Develop software iteratively with a heavy emphasis on the construction activities. So you have to do much more constructions than you do develop, like documentation and everything afterwards. Okay, more you are focused that yes, this requirement should be coded and should be shown to the customer in a very short span of time. Deliver multiple software increments, so we call them as CDRs also. In software industries, if you have someone who's working in software industry, you will get to know that it is called continuous release, okay. CDR, development releases, CDRs, okay. So development multiple software increments, you can have 30 increments in 1 month also, okay. You have multiple products, you have small, because they are very small products of maybe of 3 or 4 days or 5 days or 1 week or 2 weeks. So there are multiple projects coming up, increments. So as you have to be already on your toes to work each day. Adapts to changes that occur. Okay, once the change is there, you have to very fast in adapting that particular change. So this is what is called agile process. Extreme programming is one of the most widely used approach of agile software development. In extreme programming, uses an object-oriented approach, and it is preferred development paradigm, and encompasses a set of rules and practices that occur within the context of four framework activities. Okay, so extreme programming is one of the like heavily used approach in industry, because it is depends upon object-oriented approach. Okay, and it is widely used in industry, and the activity that it encompasses is called planning, design, coding, and testing. This figure illustrates the extreme programming process and notes some of the key ideas and tasks that are assured with each framework activity. So if you can see this, it looks similar to what we have seen for a unified process. But in the planning, what is done is the user stories are gathered, captured with values, acceptance, test criteria, and iteration plan. All these are made using in the planning phase. Requirement has already done. Then you move from planning to design. In this, we can create CRC cards. So we have discussed the CRC in our class. So those who have not were not there in the class, so what can we do? We can create a small lecture also with the emphasis of explaining the CRC. But these are class responsibility collaborator cards, which have, because once you know the requirements, you know the classes, the objects. Now you can think that which class does what work. So if that work cannot be done by the class itself, the class has to collaborate with another class. Okay, so you have to design small CRC cards, simple CRC cards here. At the same time, you need to develop spike solutions prototypes, spike solutions or prototype. The spike is a small increment that is done quickly, right? So you need to do the spike solutions, and you can to create small prototypes, very quick prototypes. After you are done with the designing part, you are doing with the coding part, in which we generally use pair programming. Pair programming means you are using two developers and one project. That means one who is actually just telling you this is a requirement. Another is the one who is actually coding. So when you have two brains brainstorming to a concept, then it's easier for the programming like paradigm, in which you can find errors. Okay, you can do much more effective work. So that's why it uses pair programming and uses a concept called refactoring. So refactoring means you are factoring the code again and again, and you want to find the you can say you can find you want to find a good algorithm, okay, efficient algorithm. And then in the coding phase, you are going to have a continuous integration. That means you create small modules, you keep on integrating the modules, and you can see whether this module fits into the earlier model or not. From this coding phase, you move to testing phase, in which you have acceptance testing or unit testing, and finally you release that particular software. So this is the life cycle of the extreme programming based approach. So other process models other than extreme programming is one of the programs called SCRM, okay, DSSD, and Agile Modeling and Agile Unified Process AUP. So we will discuss one more model which is called SCRM. Scrum Master is one of the certification that is actually used today to specify whether you are really agile developer based full stack engineer or not. The scrum, the name is derived from the activity that occurs during a rugby match. So if you have seen a rugby match, you must have seen that when the match starts, the players put the ball, okay, the ball at the center of the ground, and both the teams are coming like head on to each other, okay. And when the whistle is blown out, one person throws the ball back to his team, and then the main play starts. So the setting of the team with head to head together is what is known as Scrum. Okay, it is an agile software development method. Scrum emphasizes the use of set of software process patterns that have proven effective for the projects with tight timeliness, changing requirements, and business activity. This is one of the projects. This is a agile process that works with the strict timeline type of activities. So this particular diagram shows what is agile scrum process. So if you can think of product backlog, it prioritizes product features desired by the customer. So product backlog means you have multiple features here, and within this feature I will do a prioritizing. Okay, I will prioritize which feature is more highly needed by the customer, and which is less needed by the customer. Once I do that, sprint backlog is created. Sprint backlog features assigned to sprint. So sprint is a you know what is sprint? Sprints are very highly speed activity. Okay. So what is it? It's take one product feature, and put it into sprint backlog. The sprint backlogs items expanded by the team. So I will take one feature. I will identify multiple sub features into that. Okay, and in 30 days I will try to develop a new functionality in is demonstrated at the end of the sprint. So sprint is of 30 days. Okay. Now the sprint is of 30 days, but within the 30 days sprint, you are having every 24 hours a meeting. Okay, 15 minutes daily meeting. Okay, within 24 hours each day you have a 15 minutes meeting, because you want to keep this deadline to 30 days only. Within the 30 days you have to develop one sprint, one functionality. So for that you need to have this for this 24 hours meeting. So Scrum has 15 minutes daily meeting. The team members respond to the basic question like what did you do since last Scrum meeting? Okay, this was the first meeting, so this question doesn't come up. But when the second meeting comes, the second day, you need to tell us that we did this development, we did this particular requirement judging task, we did this modeling task, this is this construction task, this testing task. Do you have any obstacles? So if there is certain obstacle, you have to remove it at the same moment. Okay, you have to remove as soon as possible, because this timeline is forcing you to do that. What will you do before next meeting? So you should know that these are my targets to next day. Okay, now you can think of each day your manager is asking you to stand up, and the stand up meetings also there. That means they will not schedule a meeting and you call you to a meeting room and then they will discuss their have a tea and snacks. Okay, this is not the reason. They can say 15 minutes we will have a stand up meeting. What do you mean a stand up meeting? They will ask you to stand up at the cubicles or at the desk where you're sitting. They will say, okay, 15 minutes, stand up the team. Team will stand up, and those who are in that particular sprint will stand up. And the manager will ask, okay, yes, what has done by you? Or you will explain that this is what I have done by me, and this is my target for next day. You sit down. Next, you have the achieve a target or not? Yes, we have done. If you are not done, why you have not done? Because you should have some obstacles. You should have some reasons for that. If you don't have reasons, there's you are hampering the sprint life cycle of 30 days. Okay, so this is the highly productive meeting that lasts for 15 minutes only, and it can be stand-up meetings. I hope this Scrum Agile process is the diagram is clear. So the terms that we used here is explained in this slide. A prioritized list of product requirements or features that provide business value to the customer. Sprints consist of work units that are required to achieve the requirement defined in a backlog. That means whatever things have been there in the backlog, so you want to prioritize that requirements. Predefined time box, that is 30 days, and changes, that is backlog work items, are not introduced during the sprint. Okay, predefined time box, that is typically 30 days. 30 days you are not changing, and changes are not introduced during the sprint. That means once the sprint starts, you cannot add requirements into that sprints. Okay, now you cannot change the requirements. Once the sprint is done, then if the requirements comes, it adds into this backlog. Okay, if in within this time, if something comes up, if some new requirements comes up that belongs to these features, then also it adds up to into this product backlog, and it get prioritized. Now if the priority is higher, very high, it will come up to the next sprint also. Scrum meetings, like 15 minutes meetings daily, Scrum team and demos that deliver the software agreement to the customer so that the functionality that has been implemented can be demonstrated and evaluated by the customer. So this is the demo part of the particular thing. Okay. So with this we end the first unit, and I hope you understand all the concepts of the first unit in these two lectures. And as the lecture is already available on YouTube, you can see it multiple times. And if you have any doubts, you can reach me at the Google Classroom or email or WhatsApp. Thank you very much.